Okay, I'm gonna start, but if they come down to turn the lights off, then I'll pause, and maybe they'll edit it out in the video. Okay, so I've only just finished writing the slides. That's how quickly web components are changing. So the title's a bit cheeky. So why you should be using web components now and how. I'll explain why it's a bit cheeky as I kind of go through. This is the title slide for DevWeek. This is my actual title slide. So my name's Phil Leggetter. I work for a company called Pusher. We're a hosted service that makes it easy to integrate real-time functionality into web, mobile, IoT devices, into any stack that you use, whether it's .NET and JavaScript on the front end, or it's native mobile, or it is an Arduino, or whatever it is you're building. So kind of a real-time messaging pub-sub platform. This talk is obviously about web components. I'm quite interested in seeing how real-time fits into people building functionality and sharing functionality through web components. But I won't really talk about Pusher. This is genuinely just talking about what are web components, what are the benefits of web components, and building componentized web apps. So here is the summary. Can everyone see that okay? Yeah? It's a little bit faded, but it's okay. So what are web components? I'm going to go into that. I want to talk about the state of native support. So where can we use it? Which browsers can we use it in? I do want to talk about componentized web apps. I used to work for a company called Kaplan Systems and on the Blade Runner JS team. And that was all about building applications out of components, modular components. So that's why I like the idea of the native support, because I think that's the way that web applications should be built. And then hopefully I'll convince you why they're the future. We'll see. There's a really good talk by Eric Beidelman, who's been working specifically on web components at Google. I've stolen some content from him. There's no point in not saying that. It's a really good talk. I'll share the slides afterwards. I definitely recommend seeing that. He's American, so he's a bit more excitable than me. So firstly, what are web components? So it's broken down into 4 different parts. There are custom elements, which I think specifically are the most interesting. But then within custom elements, you get to use HTML templates. We've all used some sort of templating functionality before on the web, the shadow DOM, and HTML imports. So firstly, we'll cover custom elements. We all use elements on the web anyway, and they've been around forever, HTML 4.01 or whatever it was. And they offer the very basic functionality that we need. Here's some examples. They're quite difficult to style, and they're not particularly, they don't give us a lot of rich functionality. And there are a whole bunch of them, and that's how we kind of mark up and structure our apps. And then HTML5's come along, and as well as the focus has really been on the APIs that it's helping expose. But we've got, again, things around the semantic markup of our app. We've got more interesting, maybe this is slightly moving, the progress bar. We've got some slightly more dynamic things. And then we've got genuinely useful things that means we can eventually replace Flash for at least this sort of stuff, which completely makes sense. And there's things like audio and Canvas, SVG, and even math, although I haven't ever used that or tried it. So we're moving that way anyway. And the point of this element generally is that it gives us this structure, and we can, I mean, I learned HTML and I learned JavaScript by finding a site that I liked and viewing the source and looking at the contents of it and understanding the structure and diving through, following links, looking at the styling, looking at the JavaScript. And there's lots of value from that. And from the development point of view, it means that you don't need loads of documentation to understand how this thing's built or how this application's structured. You just look at the source and you dive into it and you understand how it works. Obviously, our applications are full of elements, and this is obviously Gmail. It's a good example of a complex application. We're moving loads of functionality to the web, to the front end. So we're starting to build these complex applications. But obviously, if you look at you get the idea here. If you look at the source of these things, the source, and just see this world of divs and go, right, I have no idea how that's built, where are the script tags, how is this styled, all these classes, all these inline styling, it's a bit of a nightmare. So a really nice way that we're going with this, and a way of solving this, is custom elements. It's more than just markup, as I've kind of covered. It complements all these other things, and I do think it is the most important part of web components. So what it can allow is, hopefully, So I'm not entirely sure how we're going to go with this, whether we do it quite as the example will be here, or whether we try and create these things more generically. There's a guy called Adi Osmani for Google who wrote, he's written a bunch of posts on how we should structure our web components. I think it was something like first, focused, isolated, small, testable, that doesn't spell first, something like that. So, or you could go with something like this. So this is the new Gmail, say, and we've got a header, so we've got a bit of structure. Within the header, we've got a Gmail search element, so that's the search function, the search functionality. We've got an account strip, so the bit that lets you, if you're not, like switch accounts and so on. Excuse me. We've got a sidebar, so the bit at the side that shows all the labels. In there, there's a nav, which is Gmail labels. We've got a list of contacts. We've got the main section, which is nav, and it's got that, the Gmail, the categories, the social promotion, and so on. And then we've got a list of emails. And at the bottom, we've got a little widget that probably sits and floats, which is our Gmail talk or our Hangouts. So that might be the way that we can go with web components. So I want to provide, the example I'm going to use through this is kind of a very simple one, and I'll build it up. What I'm going to do is demonstrate how you build a very simple avatar. So you can do this anyway using something called avatars.io. You set the source to be avatars.io / the service name, in this case Twitter, / the username, Leggetter. So these are the avatars for each of, I'm on Instagram, but I don't have an avatar, via my email through Gravatar as well. So to build that as a custom element, it would be nice if we could do something like this instead. We've got my avatar, we set the service name, we set the username. Now I know it's hiding away at least the fact that we're using avatars.io doing this. So that means that if avatars.io fell over, we could change the implementation to use another service or write something custom to go away and fetch our avatar based on the username and the service. So to do that, we first create a prototype based on the existing HTML element prototype. We define a created callback. So when the element is actually created, this callback is executed. I'm not quite sure why we decided to actually have the callback. So this is actually the standard. It is created callback, camel-cased, or snake-cased, or however you want to call it. I don't know why they've gone with callback, but they have. Because it's an element, we can get, this refers to the actual element that you've created. You can do this.getAttribute, username, service. And then I'm building the URL just within that function, avatars.io, service, and username. I'm creating an image. I'm setting the source attribute to the URL that I've built, and I'm doing this.append, so I'm appending it to the custom element that's created. And then you need to register it with the document to say that any time that somebody creates an element with that tag name, that this is registered and the callback will be executed and so on. And you need to provide the name of the tag that you want, and also define the prototype, pass in the prototype. So this is letting you define your own elements. So these are examples using my avatar instead. So if this is going to be tricky. Whoa. Not working at all. Should have tested this. Excuse me a second. So hopefully you should see what I can see now. Okay. So you can see that we've got the My Avatar element, and within it, this image element's been appended. And it's the same with the other ones. So we're appending this element inside the existing element, our custom element that we've defined. Okay. So you can do that by defining these custom elements, but you can also extend existing elements that exist on the web already. So we can say that an image is, this is a new definition that I've created, my avatar X, so I'm extending this image. You don't need, there's nothing specific about this X, it's just I've defined in a different example. And therefore I can put my service and username attributes on the existing image element. So again, I'm creating a prototype, but this time I'm saying HTML image element. I'm going to do the callback. I can get the username of the service, build the URL, and because I am an image, I can set my source attribute. And I get all the benefits that image provides. So it will automatically, obviously, download and show that property. We have all the properties that and attributes that images already support. So we've got title, we've got alt, we've got the ability for browsers to understand how to interact with that image and get information from it. So screen readers for accessibility, you get all the benefits of the browser already understanding how to treat those sorts of elements. So that's the benefit from extending existing elements. And when I register it, I need to do exactly what I did previously, except I also say that I extend. It seems quite interesting that you're already saying here that you're the prototype of an image element, but you still, again, down here, need to say that you extend it. Seems like a bit of duplication to me. So we've already seen one of the callbacks, but there are 4 callbacks. There's created, so when the element is actually created, when it's attached, so when it's actually added to the document object model, and when it's detached, when it's removed from the document object model, and when an attribute is changed. And obviously that's quite important because you need to know when attributes change to change what's potentially rendered in there. So on the bottom here, to do the dance again, down here, this one. Oh, that's terrible. I really should have tested this before. Does anybody know how to pop that back in? Normally there's a little icon. Anybody know how you pop that back into the bottom of Chrome? No? Oh, anyway, I've kind of got it, but it would have been nice if it was embedded below it. Okay, you'll just have to take my word for it that this does work. So on this one, if I change the service to, say, Facebook, or no, say I change the username to DevWeek, and I jump over here, you'll see that that hasn't changed at all. But if I change this one, which is my avatar changer, which has the attribute change callback, and I do DevWeek, you'll see, you could even see, oh, it did change, but then it didn't. So the URL's changed. Oh, there we go. Okay, it just took a bit of time for that image to download. So because I've got the callback registered for this attribute changed, I can actually change what's happening with my image. Okay. Does that all make sense to everyone, yeah? Pretty simple. Okay, so because it's natively supported, because it's in the browser knows how to deal with this sort of stuff, we can obviously use markup, but we can also use JavaScript to create elements. So in this case, I'm creating loads of fills. Too many fills is obviously 104. I'm going to use a do-while loop because I haven't used one in a while. And I'm going to create a bunch of my avatar images. I'm going to set the service property to Twitter, the attribute to Leggetter. I've got, obviously, an element somewhere in this page, which is called fills. And I'm just going to append 104 fills to the DOM for some reason, just to show that you can do it. So again, because you're using the native browser, you can use all the functionality that you use anyway in the browsers. So why use custom elements? I've kind of covered all of this sort of stuff already. So it's integrated directly in the DOM, so you get all the benefits that the browser provides you by it being in the DOM, by the browser natively supporting it. So you can use all the existing methods and functionality, and anything that's added to the browser you can straight away use within these components. So mutation observers that are coming along, query selector or add event listener, you get all the benefits of the browser understanding this sort of stuff and being able to natively cache and deal with pipelining and all the various performance benefits that the browser gives you. Every framework has this on interoperability point. This is Eric Biedelman's slide. Anything that can any of the existing frameworks that we use understand the DOM, therefore you can use custom elements with any existing framework. I mentioned the accessibility point, and that's obviously very important, that we can use all these attributes and the browser will natively understand all of these elements, so we get accessibility almost out of the box if we make sure that we're using the existing support for ARIA and so on. And then DevTools support first class, as long as the windows fit the DevTools, then you're in a good position. But the point is that, because it's in the browser DevTools will work, whether you're in Chrome, Firefox, Opera, or Safari, or IE, eventually. Template. So I'm assuming most people use some sort of templating functionality. Okay, so we're doing that anyway within all the frameworks and libraries that we use. So it kind of makes sense that these things move into the browser. So for instance, if you think about Jquery, Jquery was so popular because it made it really easy to select elements. And then eventually, quite a bit of the functionality that Jquery would offer was moved into standards. So document.querySelector, as an example. So we can now use CSS queries to select elements, and that came from JavaScript. So we're already doing templates. It's clearly something we do all the time, so it makes sense that moves into the browser. There are so many of these that it can't be a coincidence, so it makes sense to move this to support it natively. So we do that with the template tag. Is anybody using this already? No? No one? Okay. Mike, I bet you are. No, dude. Okay. So it's as simple as defining a template element and then defining what the contents of that is inside of it. Now, what's the next slide? Okay, so if we're using this with custom elements, we're going to create this prototype. This is my avatar temple, so it's a template-based custom element. I've got the callback. I'm going to do all the stuff that I did previously, so I'm building the avatar again. I'm going to remove that for brevity. I'm then going to grab the content from the template element. So document.querySelector, the ID of this. In this case, that's what I'm using as a selector. And I'm grabbing the content, which is obviously everything within that element. I'm then going to import the content into the document. And that gives me the element that represents. So templates are inert until they're actually added. So they don't do anything to the DOM at all. They're not really accessible until you actually add them grab the contents and add them to the document. The point in this true is to say, yes, deep clone. So clone everything that's within it. So for instance, this container also has child elements. So make sure we bring those in as well. Now, because I've got that element, I can query select to get the avatar, get the username, get the service, set values on them. So in this case, I've built my URL up here that I've hidden away. I'm setting some text this time to add a little bit more content to this custom element. And then I'm appending it to the custom element that I've created. So, and then I've registered it. I've obviously run out of slide space, which is why the example is up here. Oh, there we go. Okay, so I've created that. Oh, that's really nice. There's a nice cyan there with a white contents on it. You get the idea that something's there. Okay, so as I've said, why do we have the template element? Because people are using it anyway, and it makes sense to move it natively. We get all the benefits of it being natively supported. These things called document fragments. So it doesn't get everything that a document gets, the document object. It just gets specific things representing a small piece of a document. So it's lightweight. And as I said, it's inert until it's actually cloned and then added to the DOM. So the next thing is the shadow DOM. And the main point of the shadow DOM is to offer some sort of document object model, CSS scoping, protection. I'll explain what that kind of means. Firstly, what is the shadow DOM? So I've got to try and click on this, and we'll see what happens again. Really nice of it going. Anyway. Okay, so, whoa. So there's the video element. Now, if I go to, I can't even see it on the screen. There's an option. Maybe I can switch that over. Right, okay. There's an option in DevTools that says Show User Agent Shadow DOM. So I turn it on. Now, I've got the shadow root that appears. And within there, I've got div. I'm hiding away my nested divs this time instead. We've got this content, which is an input button, which has also got. So this is the video element. So this is how the video element is built. Unfortunately, we still use divs everywhere. But so there's the play button. There's the time as it's looping, as the cat's running around. So the browsers already have this shadow DOM in there, and they've been using it for a while in HTML5. So now they're exposing the ability to use this to developers, to us. Okay, now you've got to dig quite deep to find about these things, and I only found out about the subtrees on webcomponents.org, which is obviously a really good place to go for web components. It's contributed to by anybody that does web components, from browser body people to people in the community. There are 3 types of shadow DOM subtrees. Light DOM, shadow, so this is what I was adding earlier. Light DOM, shadow DOM, and compose rendered DOM. So I'll show you what this is. Whether or not this will be of that much interest is questionable. But so this is the custom element. So when you define your custom element, you can have content. So it's like HTML, you can have a div with content in it. Your custom elements can also do that, and I don't think my examples have that. So here I've got a quote which is hello world in a custom element. That is classed as the light DOM. So it's when you're defining your HTML in your normal document, you have your custom element, you have some content, that's the light DOM. The shadow DOM is that bit that I drilled into. So for instance, for some reason, the shadow DOM has shadow DOM. I don't really understand why. It seems a kind of strange naming convention, but you saw that I could click into that shadow root and I could see this. So that's what the shadow DOM is. It's when you drill into the content. I'll show how you use it. And then there's rendered DOM. So the rendered DOM is after the component has been built and all the magic's gone on, what's actually been rendered to the browser, what's been injected into that custom element. So it's worthwhile talking about the problems that it solves. It's already bled, so what I'm going to do is refresh that. Okay. So this is obviously an HTML presentation. This slide has got a class on it called container. Now in my custom element, I've also got a style attribute which has a container rule that sets the background color to cyan because it's my favorite color. It's not really. And then when I add this to the DOM, so let me just finish that off. Okay, yeah, so that's the complete custom element definition. Yeah, except for the JavaScript. So, oh no, hang on, that's the second bit. Anyway, if I click on me, I'm actually going to create an instance of the custom element and add it to the DOM. So remember, the template is inert until it's added to the actual document object model. Oh, right, sorry, yeah, this has got, this thing here has got a container on it, a container. So when I add my custom element to the DOM, it adds this style property, this style element with the rule on it, background color cyan. So anything else that's using the container class also all of a sudden gets that style. It's like dynamically adding a style sheet. So you're all of a sudden adding styling to the document. This is meant to be kind of isolated and on its own. It shouldn't really bleed out, allow the CSS to bleed out. If you've used multiple frameworks together or multiple, like you're using Bootstrap and something else, and there's something else that you're using happens to define BTN as a button or button-primary, then it can mess around with the Bootstrap styling. So you want to try and avoid that, and that's exactly what the shadow DOM will allow you to do. It encapsulates what's going on within the element. So in this example, I'm going to use the shadow DOM. I've got the same thing, except my rule is container background red, color white. because my custom element has a container. Now here's where I use the shadow DOM. So I've got all the standard stuff before, created the prototype, defined the callback, got my template content, and then within a custom element, you can do this.create shadow root. So that's creating that bit that you saw in DevTools, which was the shadow root bit. And now I can append things to that shadow root. So I'm importing the non-inert, the instantiated version of this actual element, this content here, into the shadow root. And then I can do things like, does that work? I think that works. I'm getting the avatar and get a username property, and I'm setting these values on it. So when I create this, although this page has a container property on it, it's not bleeding, so I can probably prove that. Oh, you'll take my word for it. So this slide does have a container class on it, so it isn't bleeding, it isn't getting that red. The background color isn't changing to red. So we're getting DOM and CSS scoping. We're getting protection for the page and the element itself. So the element isn't bleeding CSS, and the page itself isn't bleeding CSS into it. It doesn't mean that you can't, from the page, style the internals of your element. You can. There are rules specifically, selectors specifically to allow you to do that, things like host and so on, that let you do that sort of thing. And we're naturally getting that encapsulation of the styling. On the DOM, one of the things I missed. You'll notice that here, I've got an image with an ID. Now, in the document object model, there's generally a rule that you only have per page, per document object model, you have, the ID is unique within that document. So if you have multiple elements with the same ID, and you do document.element.id, you're only going to get the last one that was defined. But when you create a shadow root and put this element in there, then you can start use document.getElementById in the context of just that shadow root. So you can start to use IDs again within your custom elements, which is actually quite nice because it's the easiest way to select things. So HTML imports, it kind of provides some sort of dependency management, but it's more around loading. Now there's some question marks around HTML imports, but I'll highlight that in terms of browser compatibility. So before HTML imports, when we wanted to use something like Bootstrap, we would include all the CSS, we'd include Jquery if we were using some of the dynamic stuff, we'd include the JavaScript files all separately. Afterwards, we have a single HTML import which brings in all of these things together. So we've got one definition, bootstrap.html, which defines all of this content. The other thing about HTML imports is you can reuse other custom elements. So I can create a team pusher component. I can bring in another custom element that I've used. I can then define a template for this and say I'm going to use a bunch of these imports and add all the people that work for my company. This is obviously the definition for that. I don't really have anything. The only thing that I'll be doing here is grabbing the contents of here and adding it to the element, registering it. I haven't changed that. That was from another talk. That should say team pusher. So when I bring in my team pusher definition, add it to the page, I then get the content. Now, obviously, this is a really simple example. You might actually go that this would be a good example of where you would use JavaScript rather than the static content. You might have an array which is just all the names, choose which surface it is, all the names that you want to add to this custom element, and just do a quick JavaScript loop. It might be a bit more efficient to do it that way, nicer to view and easier to change. But that's a really simple example of composition. So we're getting that. There are a bunch of gotchas, actually, that aren't necessarily just HTML imports. This is general gotchas, actually. So when all the examples that I provided, the JavaScript, they've just said document dot, so on. You actually need to wrap your JavaScript in a closure and pass in _current script, which is like a fallback, or document.current script. That's the script that's been executed. So that's probably the link rel equals import. Otherwise, if some of this code is executed slightly later, the scope of the execution changes. Now, I haven't managed to dig into this exactly. I don't fully understand it. But you need to make sure that the document that you're referring to is actually either the page itself or the template definition. And by doing this, you get access to, I think, the template definition, like the custom element definition. I'll share the slides afterwards, and you can look at the source and see how these custom elements have been defined and how this has been used. So this is, I mean, one of the reasons I did this talk was to try and dive into web components, because ultimately we're not using them in production. So you need a reason to do it. So by going through these slides and building these things, I came across these gotchas. When I first wrote the slides, I was using clone node. So you can clone or create you can create a clone of the template in a couple of different ways. I was using clone node, but you need to import the node into the document that you want to add it to, I think. So you need to make sure that you're saying, right, well, I want this node to actually be added to the document so that it's rendered properly. So you need to make sure that you do this import node rather than clone node. Again, that's like I haven't managed to dig into exactly the details, but it's something, if there were three things like, oh, something isn't working, I remember Phil spoke about these three gotchas. This is another one. You need to make sure that you're doing import node, not clone node. The other thing that I found out this morning was I really like the idea of building, a nice little component in isolation and bringing in all the things that I wanted for that component. So I wanted to bring in a style sheet that I defined elsewhere and use it within my template within the shadow root. When you do this and add it to the shadow root, you'll get a warning which says you can't import, you can't use link within the shadow root. You can't bring in additional content. So, which is a complete pain. I wanted to use something called animate.css to add a nice spinning effect or something, but I couldn't use it. It was saying, no, you can't bring that in. So that's another gotcha. I haven't looked into script, which is obviously quite important. If you're going to build a component that has some third-party need for some third-party support, can you bring the script in to the shadow DOM so that it doesn't naturally add things to the document and to the window at the top level? I don't know. There's another gotcha there. So, going back to HTML imports, we get to bundle and do some sort of dependency management through that bundling. That it's a lot easier to import and share this sort of functionality. And I think one of the main things is it supports composition. If you're building loads of different components and you want to build a slightly more advanced component, you can compose that advanced component of the smaller components that have been built. It's the way that we've been building web apps anyway. So it's kind of supporting that. So the important thing is state of native support, obviously. As you'll expect, Chrome are absolutely leading the way. Firefox, I think that might be wrong. I think they might support custom elements now. But basically, you can use them in Firefox. Safari and IE, I think you kind of expect it to look a bit like this. In Firefox, you can definitely enable things like shadow DOM and HTML imports. About a month ago, Mozilla announced that they weren't going to support HTML imports anymore, because if you look at the ES6 spec, it says that there's a way of including modules. So they're not sure which solution is going to be best. So they're saying, well, we're not going to support HTML imports anymore. You can still turn it on in the dev flags in config, but I wouldn't rely on them being used. The other thing that they say further down here, this is the link to the announcement, is that it's so easy to polyfill, it's so easy to add that functionality anyway, that it isn't adding a lot of value by natively supporting it, apparently. Who uses IE as their main development browser? Okay. The dev tools are actually pretty good. I do think they're pretty good. But as ever, we kind of wait for IE to catch up. Now, IE are obviously much more progressive than they used to be. It's now going to be called Microsoft browser or something. You know, they're ditching the IE brand. They're building the Spartan rendering engine, removing all of the cruft that was in there before. And custom elements and all the other things in the background are under consideration. These are the 4 things. So, you know, IE saying, maybe. But if you look at this should be playing. If you look at their feedback, so there's a user voice forum where people can vote for the features they want in Internet Explorer. Now, positions 2, 3, 5, and 6 say that they are the 4 web component standards. So the community wants support for web components. Hopefully, IE will listen. Oh, that has played. It's just... I'm not going to try and mess around with that again. OK. Safari, it's kind of like a closed book. I don't think anybody really knows what's going on at Apple. Apparently so in Eric Bardelman's talk that I referenced earlier, he said that Shadow DOM was in Safari and then it was removed for some reason. But he also says in that talk that it may be coming back. There was something about the implementation that went away as it'd be coming back. So, I mean, I guess it looks like the state of it. You know, I've said why you should be using web components now, and you're now going, well, you can't use it now. This is the only GIF I've got. All is not lost. We can, more GIFs. I should have done more GIFs. So when you there's something called webcomponents.js, which is the polyfills for all of these things. Now, it basically polyfills everything with the exception of Shadow DOM. There's a bunch of limitations around Shadow DOM, and I didn't have time to add them all, add them to these slides. But there are things that won't work there, like CSS selectors and various other things. You can't really polyfill the fact that there's this natively support shadow root within the browser. There's no way of just hacking around that. So what I'm really saying is that you can build componentized web apps now in the belief that web components are going to be the standard moving forward, and then the transition from building componentized web apps to using native web components won't be as big. And if you look at some of the libraries, then that transition isn't that big at all. So a couple of questions. So should they stop us thinking about web components? Do you think that's the case? Do you think that the fact that the browsers don't support them, should we not be thinking about web components? I'm going to say no. I think it's important. I think it's the way things are going. And should we be building components as web apps anyway? I would say a lot of developers are already doing it. So we should be definitely thinking about building web components and thinking about building our apps out of components. Because JavaScript libraries and frameworks. So I want to go into this and explain what I mean by that. So who's using Angular? OK, a few people. Cool. So let's include Angular. I'm going to have a module called demo. I'm going to create a directive called ng-angular. From that, my definition is going to say, basically, you can define this directive and instantiate this directive by either using an attribute, by using an element, like a custom element, or a class. I'm going to say the scope has 2 properties, service and username. I'm going to say the template is an image, which is avatars.io / the value of service and the value of username. On my body, I'm saying ng-demo. I'm using the kind of avatar, the avatar custom element for Angular, ng, that I've just defined. And this is the result I get. So is anybody using Angular and using directives? OK. So you're already kind of doing web component or component-based. And how similar is that to native web components? Anybody using Ember? OK. So Ember has components. It has a bunch of dependencies, which would be nice if they were brought in with an HTML import. We create an application. Now, Ember has a specific set of conventions to create components. So we're saying em avatar component, and then we ember.component.extend. We're saying we're building a URL, which is avatars.io, this.getService, this.username. And we're also saying that we've got 2 properties, username and service. The way that Ember works is that you use handlebars, which is why we included it. In there, we're saying that we're component /em avatar. So Ember maps this knows that components is a namespace of an ID. EM avatar maps it to the fact that this exists, EM avatar component. And then we can bind the source attribute of this image that we've defined with the URL that we've built here. And then when we want to use it, we need to use handlebars to instantiate it. There may be other ways of doing this, but basically this is my actual app, and I'm saying, right, I'm going to use the double curly bracket, EM avatar, service Twitter, username Leggetter. I can show you that in action. Give me a second, where's my mouse? Okay. Unsurprisingly, it looks exactly like all the other examples. So this is, the rendered output of this. So, if you're doing Ember and you're using components, you're building things in kind of a web component way anyway. Who's using React? Okay, 2, cool. Okay, so in this example, I'm going to include React. I'm actually going to do my transformation in the browser. So React, part of what React will do is it can render the contents on the server and on the client. Generally, you would do some compilation on the server and serve up a compiled version of this, but I'm going to use this JSX transform and do my transformations on the client. I'm going to define my avatar component. And in here, this is this crazy, it's not crazy, some people love it. This is their specific syntax. So you notice here, this isn't a string that we're building. This is specific kind of markup. We're returning this in parenthesis, building up this image. We're using angle brackets, building up, now we are building up a string, avatars.io. This.props, which is saying I've got properties, service and username. And then we can render that component. That should just say render in 0.13. I upgraded from 0.11 to 0.13, and this should say react.render. The code's changed, but this hasn't. I'm saying this RE avatar, which I've defined up here as a variable. I'm saying service, username, and then the only way that I could find, there doesn't seem to be a nice little layer which lets you define things in HTML and then just does the mapping. So here I'm building this and then actually adding it to any element that has, the first element it finds with RE avatar, it will add what the rendered output of this, so basically this content. So I've defined that and stuck it down there. So that works too. And if you look at any of the libraries that who uses Knockout? Okay, quite a few people. So who's using Knockout components that came out in 3.2? Okay, 2. So Knockout have got components in there as well. Backbone, I don't think it's native. I think it's another extension of Backbone. And you can combine all of these things as well. There's Backbone with React components, CanJS. There's a bunch of other frameworks that already have this idea of components. Has anybody played with Polymer? Not surprising. Okay, so Polymer is, right, it's really important to emphasize this. Google have been doing a lot of talks on web components, and it's great that they're pushing the web forward and doing all this sort of stuff. But they give a talk on web components, and they dive straight into Polymer. And people are getting confused that Polymer are web components. Now, Polymer is a framework built on top of the standards of web components. So it uses the fact that web components will exist and then builds on top of it to make it even easier to build web components. So we've got our native support. This is, again, a slide from Eric Barnum's talk. So we've got our native support. We've got platform. Now, platform is now web components.js. I haven't had a chance to update this. So this is called web components.js. It was called platform. And web components.js is a shared polyfill amongst all the browser vendors are contributing to it. It's an open source thing. And then Polymer is built on top of web component standards. And then Polymer also introduces the idea of Polymer elements and a bunch of reusable elements that they've created. So to use Polymer, you need to include the polyfill. In fact, in Chrome, I don't really need to do this because web components are natively supported already. Unsurprisingly, I import Polymer. I define a Polymer element. I say I'm going to be a Po avatar. I need to define which attributes. It seems quite strange that it's space delimited. Service and username. I'm defining my template. I'm saying that I'm actually building an image. You'll notice this nice kind of shorthand that we saw in some of the other frameworks where we've got double curly brackets, service and username, so it knows when it renders this to grab it from the attributes. And then I need to register the per avatar, and that's it. So you can see that they've really squashed that down and made it really easy to build Polymer elements. And then to use it, I just go per avatar, service Facebook, username Leggetter, and it renders. Again, I'll share the slides, and you can look at the code, and it is that code. So really easy. So I thought it was worthwhile showing what the sort of things that Google are doing as well. So remember, web components, Polymer, separate. And then on top of Polymer, they're building reusable stuff. So who's heard of the material design things that Google are doing? So the Polymer paper elements implement and show this kind of material design, this nice experience that Google has spent quite a bit of time working on. And if anyone uses an Android device, all the applications are moving to support this material design and paper style elements. Those that use Angular, there's also material.angularjs.org that lets you do all this sort of stuff. And you'll notice everything is a kind of custom element again. And you use them by adding markup. So who isn't using one of those frameworks and using markup and building some sort of componentized web app? Who is building some sort of componentized web app using directives or components or... Okay, so people are lying or just not participating. That's all right, I understand. Okay, I'm kind of hoping that this is like, you're all using building componentized web apps. So, if you're using any of these, you've the opportunity to be building components. If you're doing something like this, you're already building componentized web apps. There isn't much of a difference from using real web components and custom elements. That's Angular, that's custom elements. So there's some good examples. GitHub already use custom elements. Although this does involve, is that going to even open? Where's that gone? Oh, okay. Now, can anybody see a time? There we go, look down here. Oh, there we go. Right, so you'll see. Now, time, I believe, is an HTML5 standard, but they've got is, relative time. So they're using the web components polyfill and adding this ability to add relative time because it's something that they quite, who uses GitHub? Everybody should be using GitHub. They've identified that that's a common piece of functionality that they want to offer everywhere. So they're going, well, it's going to work anyway, but if I can use web components through the polyfill, which most browsers will support, I'm going to actually do this 23 minutes ago rather than specific timestamp. Chrome. Has anyone got a Chromebook? No, me neither. Oh, one person. Did you go to Google I/O? Did you buy one? Yeah. Nice? Yeah. So there are loads of things in Chrome OS, on Chrome OS, that are built using web components. Makes sense. It's basically Chrome that's running. It supports web components. Eric Beidelman also built Gmail. There we go. So he built it using Polymer. So this is actually my email that's loading. So if you go to poly-mail.appspot.com, it'll ask you to log in, and these really are my emails. It's not fully functional, but it's Gmail written in web component, well, Polymer built on top of web components. If we view the source, it's not bad, but you'll see they do have a Google sign-in, which is quite nice. They've got a material search, which we mentioned the material stuff already. Now, they've got these core things. They're obviously elements that they kind of offer anyway. So they're not going quite as specific as the example that I had. They don't have like a Gmail search. They haven't gone specific into the application and built. It doesn't look like they've built web components or Polymer elements specifically for Gmail, but they've built more general Polymer or Google-based components, and they're reusing them here. And you'll see that there's things down here like paper items, template. I mean, it's better than the current Gmail, but it's still not quite as semantically readable as I was kind of hoping. But that's, I mean, you know, it's software. We can write it as we want, to be honest. There's another really quite a cool one, just to show that you can really go extreme and completely remove the nice readable nature of this sort of stuff. So again, it's quite nice. It looks kind of very materially and papery. And if we view the source of this, so you can completely break the web still. Oh, I can see what that's doing. Look, there you go. It's easy, isn't it? That's rendering the SVG things. Yeah, okay. So you know you can still create very difficult to read web apps. There are obviously values to this. You know, if you compress everything and chuck it into a single HTML file, it can be served faster and load faster and so on. But I think you need to get the balance right. So there's some examples. So why are web components the future? I think I've already kind of covered this. Some of you are already building componentized web apps. And if you're not, you probably should, because the trend, you know, you've seen all these library support components, is that that's the way that the libraries are saying build things. That's the way the browsers are going. Again, trends and demands. So the libraries are aligning Angular directives, Ember components, Knockout components, Polymer, and even Angular 2 very specifically is looking at components. The Quick Start Guide, for instance, step 4 is define a component. So if you're thinking I'm Angular now, or I'm Angular in the future, or I'm going to migrate to Angular 2, you're going to be starting to think about components, templates, and so on. I mentioned the browsers are supporting this. So we've got Google, obviously. Google uses Blink. Opera uses Blink. So Opera is probably a little bit behind Google in terms of adopting this sort of stuff. But eventually, anything that Google will support, Opera will support, so they'll support web components. I missed them out of the table just due to size, and because they use the same rendering engine. Mozilla are kind of moving that way. They will support custom elements. They will support template tags. They probably already do. They will support Shadow DOM. The HTML imports is questionable still. Microsoft, I'm pretty confident that Microsoft are going to go that way. Did anybody ever use hypertext applications with Microsoft? Like i6, does that just show my age? Or ASP.NET controls, which are very kind of component-based, thinking about building component-based apps. And we saw the IE user voice thing, and Apple, again, we don't really know. So as I said, with IE, it's massively in demand. What is it, 2, 3, 5, and 6 of the top demanded pieces of functionality in Internet Explorer by developers. And I would argue that, as nobody was in my talk yesterday around, what was it, very buzzwordy, building enterprise scale HTML5 applications. No, lucky you. I mean, a lot of the stuff that I did in my last job at Blade Runner, with Blade Runner JS was about building componentized web apps, and there are loads of benefits of doing that. So you can look at component-based development and read the Wikipedia article or read any sort of software engineering text and look at the benefits of component-based development, which is very modular, and you'll get all the buzzwordy things. But what we're really talking about is separation of concerns. So when we normally talk about separation of concerns on the web, normally we're given the example of HTML for content, CSS for presentation, and JavaScript for behavior. But what we're doing really is we're separating into feature. So that's, you know, these components are features. So we're saying search is separate from account, is separate from contacts. So we're separating our concerns in terms of feature. We've got a little Gmail talk thing down there. We're getting encapsulation. That's the point of the shadow DOM, is to encapsulate things. One of the interesting things is I kind of hoped that the shadow DOM would also encapsulate what's going on in JavaScript in that component. And that isn't the case. So here I've got a hacky element, and it says, don't click me. So I'm going to click it. So I've clicked it. So this is defined in the shadow DOM, the JavaScript and everything. But I can do top.document.write, this.outer.html, and all of a sudden I've taken over the whole of the page. So you need to, if you're starting to include third-party custom elements, then you need to think about that in exactly the same way as you do with third-party JavaScript. Now I've totally broken anything. I need to reload that. Yeah, so I was kind of hoping that it would also encapsulate JavaScript and provide us a layer of protection, but it doesn't. We get some form of loose coupling. So the synopsis for the talk was going to go on about, well, does talk about how we get loose coupling through this. Now, it's not enforced. You've seen that the JavaScript there can reach out of the page. Now, I know of people that have created a custom element, added Jquery to the custom element, and then reached out of that custom element and started pointing specifically to other custom elements that exist within the application. Now, that's not loose coupling. That component now relies on all these other elements existing in that page. So when you remove one of these other elements, that custom element completely dies. It's not got one of its dependencies. But if you think, it's quite interesting, you need to start thinking about the way that you use native elements is exactly how you should be using your custom elements, your web components. So you've got custom events. So in terms, we've already got click, mouse move, all the events that we've got. We can also define our own custom events. Now with jQuery, you can do that too, but it makes sense that you can do that with these as well. And also the element itself provides an API. It's got attributes. It's got, in the same way that the elements, like the video element has a play function on it, your web components can have their own functions too. And because you can reach out, you can use existing message, if you've got a message bus of some sort, or you're using Angular services, or any kind of service-based solution, you can use that with your custom elements. But you're adding, obviously, a dependency as long as you keep that dependency small, because you can obviously reach out and start interacting with like a message bus that you've defined within the app itself. Polymer has a core message bus or something as well. So they've added this idea of this sort of stuff already. There's also things, data binding is also part of Polymer. So you can share an object and communicate through data binding on these properties as well. But that's not specifically web components, that's more Polymer. So for custom events, I'll create my element. I'm actually going to add a click listener to my component. When that happens, I'm going to create a new, I don't know why I'm going to do this, but I'm going to do it. I'm going to create a new custom event. So this is natively supported custom event. You can provide additional things you pass in a second parameter and with a property of details, you pass more information. So my event's called cheese. And then I can call this.dispatch event. So any node, any element, you can do this.dispatch event and then pass that event object. So in this case, and then outside of that, completely outside of this, you should be in a separate script tag. I can get that element. I can add an event listener for the cheese event. And then I can say cheese fired, because that's what you do with cheese. And then this is obviously how I define it and use it. So when I click on it, I'm getting cheese fired. So we can create those custom events and use them within our app, outside of the element. We've also got the attributes. You saw me change that attribute anyway. So if you do set attribute on an element, you're invoking the API that element exposes. You've also got these functions as well. So on the prototype, I'm saying start spin and stop spin. And then if I execute this, I'm going to have to open my DevTools again. That won't work, but I can do. So I'm getting the element, and then I'm saying start spin, and I'm spinning, and I can do spin, stop. And stop. And you'll see, even because Chrome understands these custom elements, it's even giving us the autocomplete and telling us what that this is actually available on it. So I can stop spin, and it will add stop Jquery. So we can interact through the existing APIs that all elements can define and expose. I don't have any content for this, but if you think about it, if you build anything that has a very strict interface and you're hiding away what's going on inside, you can change the implementation. I spoke about the way that at the minute I use avatars.io, but I could use another. I could change the implementation as long as the element name, the attributes, and the functions that exist on that element stay the same. I can change the implementation. So straight away it's supporting change. And the way that the web's moving, it makes sense that you're encapsulating your functionality in something so that you can change as things go on. So when you build your apps with Socket.io or SignalR, and you decide you want to scale those apps out to millions of users, then you can use Pusher, that sort of thing. And reusability, I've mentioned this already, HTML imports, you can bring this sort of stuff in. Now, whether or not this will be the way we go forward, or whether or not ES6 and the way that we import JavaScript will kind of win over, there will be a way of including and reusing elements that have been defined in other projects or that people build and share. So for instance, things like the Facebook and Twitter and all the widgets that we add to our kind of social apps to encourage social engagement and sharing, they will become web components. They won't become script tags that you include that dynamic write an iframe and do things. They will be web components. And we naturally get high cohesion, which is another great software engineering buzzword. What that means is we're keeping all the things that are related to the piece of functionality that we're building together. So we've actually got functional cohesion. We've got my avatar, I've got all the JavaScript. Now, I obviously wrote this before I worked out that the CSS thing didn't work. You can include it outside of the template, but you're keeping all of these related things together, on disk together, so that as part of that development process, you know exactly where to find all the files, all the definitions, everything related to that piece of functionality. It's not all unicorns and rainbows. There are questions. There's around HTML imports, what's going to happen there? But there are solutions. So if that example I had with all the munged content, now that was probably built using something called Vulcanize, which understands the structure of HTML imports and will bring all this stuff together and concatenate things and add them together and stick them all in the document object model. While I'm thinking about it, the problem that I mentioned around not being able to bring in an external CSS file into your template and put it into the shadow DOM, Polymer actually works around that and will see that you've referenced an external CSS file and inline it into a style property. So there's tooling to support some of this stuff. As I mentioned, I haven't really looked into how we share JavaScript, so I'm not entirely sure if you add a script to your element, to your custom element, and someone else uses the same script, I'm guessing that you get the benefit of the browser cache, and I'm pretty sure if someone else has used the same script, you get browser cache. You get to use the browser cache. But what happens if you include the Pusher library 1.5 and someone else uses a web component that uses the 2.2 library? Now, does that live within the shadow DOM and therefore not overwrite the original definition? Or does that break stuff? So yeah, how do you deal with this multiple versions? I still feel like the way that we're still being given enough rope with web components to hang ourselves. I think we need to improve the way that we're going to communicate between these components to make sure that we are building things in a loosely coupled way so we can support change. It's down to us to make sure that we're following good practice rather than there being a little bit of enforcement. I think we could do with that personally. I can't understand why we can't include a link in the CSS shadow DOM. So that's it. I'm actually way ahead of time. I've got 25 minutes, no, 25 minutes left. But in summary, I mean, is everybody else relatively excited about custom elements? Are they pretty cool? Yeah? Okay, a few nods. hopefully. Speak to me afterwards. I'd like to know. I genuinely think that that's the way we should be building applications. I like the fact that we can have a nice, semantically rich and readable HTML again, and we can encapsulate that functionality in custom elements, which ultimately, for me, that's like you use custom elements straight away, and then you start to take benefit of all these other things. And we get all the native support because the browser will native support templates, shadow DOM, maybe HTML imports. We're getting the encapsulation of shadow DOM, which is really valuable. Some of you are building componentized web apps now. I believe you should be because, as I've said, the browsers are going that way, the libraries are going that way. It means that if you're building applications in that way now, it's easier to switch over to the native support, whether the library that you're using will just naturally go, oh, I can use web components and start using them, or whether you need to make a few tweaks just to actually use native web components instead. You get all the benefits of the browser natively supporting this functionality, and all, which is great. As I said, we're moving that way anyway now. So I believe web components are the future. I hope I've convinced a few of you too. Plenty of time for questions. Questions?
You mentioned when you had the table of compatibility, where does it stand with like mobile versions of the browsers?
Okay, yeah, I'll actually show you that. Okay, so the question was, where do we stand in terms of mobile versions of browsers? So most people use can I use, is that right? Can I use, oh, not WebSocket. I'm sure there's like an are we ready yet for web components. If we look at custom element, no. Yes, obviously, because it's Chrome. These things are both Chrome. So it's pretty good there. I mean, again, with the polyfills, you get the support. Templates. Everywhere except for Opera Mini. Anybody use Opera Mini? No, okay, we're all good there then. Shadow DOM will be tricky. So again, not bad. You still got the iOS support. I think it's worth looking at the webcomponents.org. We'll probably have a. I'll show you webcomponents.org. It doesn't have a compatibility table. I know what, I'll Google it for you. Can we use? Whoa. Firefox on hold, custom elements. That's not really telling us about the I'm sure they'll be quite easy to find reference, but I mean, the polyfills will work because I think Safari, it looked like Safari on mobile is the main problem, but it's pretty close to Safari on desktop. So, any other questions? Yep.
How far back is the polyfill support, like things like IE or even the Android browser?
I think it's I10. Yeah. Any other questions? Sure. Yeah, so you can use all the dev tools. So when I was building the slides, I could put debugger in the JavaScript. I can, you've seen that I can inspect elements and go into the shadow route. So you get everything, in Chrome, you get everything that you get outside of that because it was natively supported by the browser anyway. I showed the video element where, I guess they've been using these tools forever. It's like if you see Ade Osmani give a talk about the Chrome dev tools, you're going, I have no use for that crazy stuff yet. But obviously they are building web-based applications, and they probably are building much more complex and demanding much more of the browser than we are. So they're actually the ones driving the tools that eventually we'll need, and I think they've been using web components for a while. Any other questions? Sure.
Do you see this web components replacing things like Angular?
I don't think so, no. So the question was, will web components replace Angular? There's a bunch of videos on Angular 2. I'm pretty sure they're aligning themselves with web components or they're using web components. So no, I think, as I kind of said, the libraries are moving in that way to either use them or put themselves in a position where when web components are supported everywhere, they'll use them, or they'll just say, right, we don't do the component thing now, we add a layer of additional functionality and value on top of web components, like the way that Polymer does. Any others? No? Okay, go get coffee. Thank you very much. I'll be here all day, so give me a shout. Thank you.